Looking at the first problem, it says the following figure is a parallelogram. So we've got a few properties we need to remember about those. And one property I'm going to use on this one is the fact that opposite are congruent. Okay. So it wants me to solve for x, so opposite sides are congruent. That's going to let me know that LM is congruent to PN, therefore their measures are equal. So I just fill in what I've got. LM is 9x minus 25. PN is 5x plus 7. Doing the algebra to solve for x, I'm going to subtract 5x from both sides. That's going to leave me with 4x minus 25 equals 7. I'm going to add 25 to both sides. So 4x is going to be equal to 32. Divide both sides by 4. I get that my x is 8. That's number 1. Okay, let me clear this. Number 2. The following figure is a parallelogram. So again, I need to be thinking about those properties. They tell me that NS, this portion right here, is 2x plus 7. They tell me that SQ, the portion from here all the way to Q, is 5x minus 23. And they want to know what the length of the entire diagonal is. Well, I know that diagonals bisect each other in a parallelogram, so that means if I can figure out what NS is, SQ is also the same thing, and then I can just double it. So the first thing I need to do is actually find what x is. So I'm going to use the fact that diagonals bisect each other. So I'm going to say, well, NS has to be equal to SQ. So filling in, I've got 2x plus 7 equals 5x minus 23. Doing the algebra, I'm going to subtract 2x from both sides. That's going to leave me with 7 equals 3x minus 23. Now I'm going to add 23 to both sides. And I'm going to get 30 equals 3x. Divide both sides by 3, and I get x equals 10. Now again, I've already decided if I can just figure out what NS is, SQ is the same thing, and then I can just double it. Okay? Or if you want to think about adding NS plus SQ, you can do that also. So finding NS now, NS is 2x plus 7. I now know that x is 10, so 2 times 10 plus 7 is going to give me 27. Therefore, SQ is also equal to 27. So NS, adding the 2 up, or just thinking about doubling it, is 27 plus 27. So NS is 54. All right, next problem. Right, here's a rectangle. In order to do this problem, I need to be thinking about all the unique properties that go along with it. They give me some numbers to work with. The first question they ask for is, what is AC? Well, I'm going to say that AC is 42. And the reason I'm going to say that it's 42 is because DB, the other diagonal in this problem, is also 42. And one of the properties about rectangles here is that the diagonals are congruent to each other. So if DB is 42, AC is 42. The next one, EB. EB is this portion right here. So I know, again, just like parallelograms, not only are the diagonals congruent to each other, they bisect each other. So I believe that EB is going to be half of, because again, they cut each other in half of whatever DB is. And they give me that in the problem. So I've got half of DB is 42, therefore EB is going to be 21. continuing. They want to say BC. Well, if AD, y'all, go back to my problem. If AD is 26, BC is also 26. Opposite sides congruent. The next one, AB. AB. Well, to do this problem, this is what I want to know. What do I know? Let's see, I know that AD is 26. The entire length of DB here, I know that it is 42. And I know that angle A is a right angle. So what I can do, I can pull out this portion that I've got highlighted here in green. And I can look at it as being a right triangle. So I've got 42, 26, and if I want to find out AB, that's just going to be Pythagorean theorem. Now online, if you look at the worked out solutions, I worked the Pythagorean theorem already out. If you do it correctly, and I'm going to round to the nearest whole number, we should get about 33. The measure of angle ADC. I'm going to go back to my rectangle. ADC is this entire angle D. And remember, all four of your angles in a rectangle are 90 degrees. ABD. So I'm going to go find it. ABD is talking about this small portion of that angle. Okay, here's a little hint about rectangles. What's nice about the diagonals, they always split their angle in a unique way. So I'm going to use the fact that DAE is 52 degrees. Well, if it's 52 degrees, and remember the entire angle A is 90, 90 minus 52 is going to give me 38 for this angle. So now I know everything I need to. Every diagonal is going to split that 90 degree in this particular rectangle. Not all of them, they split them differently. But in this particular rectangle, it's splitting that 90 degree into 52 and 38. So now I know a lot of stuff here. I know that this is 38 degrees, which is what I wanted. But not only that, I know now that that's 38 degrees, and that's 38 degrees. And these other smaller smaller three angles of this 90 degrees. So I'm looking here, here, and here. I now know that they're 52. A little handy piece of information. Okay. So let's see. The next one, BCA. BCA is this one. Oh, I just found that last time. I know that it's 52. And lastly, I'm looking for angle DEC, which is this one. Well, again, I know that these inside angles in this particular rectangle, 38 degrees here. So if I focus just on this being a triangle, I can do 180 minus 38 minus 38 and get 104. All right, next problem. Properties of a square. A square adopts all the properties of a parallelogram, a rectangle, plus some of its own. Okay, here we go. First one, PR. So I want to know, what is this diagonal? Well, if TR is 17, that means this is also 17 because it adopts that from parallelograms and rectangles. So I know if I add the two together, I'm going to get 34. QS. Well, QS is this diagonal. Diagonals are congruent in this case, so that's also 34. QT, that's going to be 17. PQ. PQ takes on a property that's just unique to squares. Okay, so PQ's this. That's what I want to know. I know that this is 17 and that's 17. What's unique about squares and their diagonals is that they intersect in such a way that they are perpendicular, which means it makes a right angle. So in order to find PQ, I'm just going to pull this out. So I've got 17, 17. Up here is PQ. And I can use Pythagorean theorem. If you do Pythagorean theorem correctly, and I'll leave that for you to do, you should get 24. Which is really great because if PQ is 24, I know the other three sides of the square here are 24 also. Now let's find some angles. Next, what's really nice about a square is that the diagonals don't just split it in a unique way and I have to find it every time like a rectangle. In squares, diagonals always split those angles the same. They split them in half. So I've got 4 right angles here, which means they're being split in half, 45 and 45. So I've just got to figure out with these angles questions over here, am I talking about the entire angle or just a portion of it? So PRS. PRS is just going to be this portion, which means half of it. Next, STR. STR, remember that diagonals bisect each other in a square, so that's 90 degrees. Next, I've got PSR. Going to look for that PSR, that's going to be that entire angle S, so that's 90 degrees. And lastly, looking at QPR, that's 45. All right. Number 5, I'm looking at the fact this thing is a square, and I'm trying to solve for x. Well, again, guys, diagonals cut this 90 degree in half. So if I'm looking for that, I know that 7x plus 3 is equal to 45. Doing that, doing the algebra, I get 7x equal 42, subtract 3. Divide both sides by 7 here, I get that x is 6. X is 6. The last two problems deal with interior and exterior angles. I'm going to kind of shorten some things up here. Just know that, first of all, I've got to figure out, well, I need to solve for x. I'm dealing with interior angles. So if I can add all these up and set them equal to something, I'll get my answer. Okay. But I just don't know what to set them equal to, so I'm going to show you that part. So I've got 1, 2, 3, 4, 5, 6, 7. I've got a 7-sided figure, and all these interior angles should add up to, I'm going to use this to let me know, all these interior angles in this 7-sided heptagon here should add up to 900. So continuing this out, and I'll let you solve this, 120 plus 7x minus 64 plus 5x minus 4, and so on, so you've got all of them, equal to 900. The last problem, exterior angles. I don't care how many sides a polygon has. All exterior angles add up to 360. So they want to know the measure of angle BCA. Well, I know that BCA right now is 10x minus 37. So if I can find x, I've got it. So I'm just going to add all these up and set them equal to 360. If you do that and do the algebra correctly, you should get that x is 16. Now I'm going to plug that in. 10 times 16 minus 37. I should get that BCA, that exterior angle, just that one, is 123 degrees.